In previous lecture, we have seen that how to build a binary search tree. And in this lecture, we will simply extend this concept to the higher dimension. So to higher dimensions means k dimension. We call this tree is a k dimensional tree or kd tree. K dimensional tree, or simply it is called the kd tree. So we've seen in binary search, we have seen that in binary search we have seen we are given a sorted array of number. Sorted numbers we are given, and on the sorted number we have to find the positions of a particular numbers. And here we are taking the numbers is a simple a scalars or simple 1D or simple 1D. Here we have seen in previous lecture these examples. Now here we are considering in this lecture we are considering our data sets is 2D or 3D. If it data sets is look like n dimensions, then what will be the structure of the tree on such cases? So for simple set here we are using simple two-dimensional case, and if you just understand the two-dimensional case, then I think you can easily extend this concept for the higher dimension. So let's draw the first pictures. I think play with pictures, it will be easy to understand all of it. So let's build a KD tree. Suppose first draw a axis. Okay, let this is our sample plane. This is our sample 2D plane, and let's take our points is just look like the blue color, just look like the blue. Suppose our first point is here, that we called first point is here. Second point is, suppose let's take here. Third point is, let's take here. Fourth point is, let's take here in such a way. Fifth point is here. Sixth point is also here. 6, 7, 8 point is here. 9 point is look like in such yes. 9 is here. 10 and 10 is look like here. Suppose look like this is our sample the data points spreading in our in whole 2D plane. This is and also we have renamed this point. This is our first point, this is our second point, this is our third point, this is our fourth point, fifth point, sixth point, seventh, seventh, six. I think I have done some mistake. Okay, no problem. 6 point, 8 point, 9 point, and one more. So let's take here. Okay, so just first write down the this point. Just first write down corresponding x-axis. Suppose it's suppose let's take it's our x-axis, it's our y-axis. First write down the corresponding image of the each point. I'm here using the pink color. So the image of the 1 will be here, image of the 2 will be here, image of the 3 will be here, image of the 4 also look like here, image of the 5, 6, 7, 8, here 9, and also here 10. Suppose look like this is the image on the x-axis of our data point, and similarly for y-axis also they have image. Suppose let's take in y-axis 1 here, 2 here, 3 Okay, okay. Just omit this, and when we record, then we can easily look at first let this is our sample, the image of the data points in x-axis. Now what I have to do? First, pick a x-axis. First we have to pick the x-axis and then project the points onto the x-axis and compute. First we have to compute the median of this point. Okay, first we have to compute the median. According to the median, just simple for binary cases, as we are doing, just I am taking the, instead of single scalar point, I am taking the image on the x-axis as scalar. Okay, so first just write down these things stepwise. So what we have to do in first step, we have to pick x-axis, okay, and project the points onto x-axis, and compute the median. Compute the median. Okay, first you have to project this one and then compute the median. And after that we have to we have to split the data sets into according to the median. At that we have split the data set and by simple using the median. This is the first job we have to do. So let's come to our data set. So what will be the median of this point? So the median will be 10, 5. I think this thing will be the median. I am using another color. I think this will be the median, 5th point. This will be the median of this x-axis. So what of this median? Just splitting this point on this according to this median using this. So if we just sample the straight line, this look like this. This is the first split. This is the sample's first plating we have to make. This is the first plating by simple using. Okay. So let's take this point is x1. Let's take this point is x1. Let's take, or sometimes let's take this point is actually x1. Now what are these? What are the equations of this line? That is the parallel of the y-axis. It is parallel of the y-axis, so its equations will be x is equals to x1. Simple, these equations will be x is equals to x1 if this point is median is x1. If then these equations of this line is x is equals to x1, and the point left side of this plane will be less than x1 and the right side of this plane will be greater than x1. Just I am using this concept and build the equation. So let's write down one by one. And so first I have making a conditions that x1 less than is equals to x1. This is the first conditions we have to decide these conditions. And if this is yes, then it will be the left side of the x1 plane, splitting plane, and if we know, then it will be the right side. Okay, this one, this thing. Now what are doing in the next step? We have just changed the axis. In this step we have taken the x-axis. In the next step we have taken the considered the y-axis. The second step, what we have to do in the second step, we have doing event. In second step we have to doing the taken the alternative axis, alternate between axis. So in this case we have considered the y-axis. Okay, so just if you consider the y-axis, first I am consider the left side of this plane, then I am going to the right side. So if you just consider the this side plane, so what will be the point? This point is 1, this point is 1, 2. Just project this point on the y-axis, because I have now altered the axis. Now project the point 1, 2. So 1, 2, what, or and here one thing, here also we have point 5, here also 3, here also 4. We have this point, that is 1, 2, 3, 5. Now what is the median of this among this all this point? So what is the median? So median is this point, this thing. Okay, 5, 3, 3 or 5, 5. I think this okay, I am doing something. It will be 3, it will be yeah, it will be 3, it will be. So the median of this among this point is 5. So now we have splitting the same thing, repeating again. Now I am going to split this plane according to this median value. Just a minute, just take the straight line. It will be better. Just I am splitting this point on this using this using this median value. Okay, then same thing also repeated here, same thing also repeating here in this in that side also. Just first write down this thing, and that's first write down. So suppose let's take this point is y1. Suppose let's take this point is y1. 1. Now what? Now what we have getting here? If y less than is equals to y1. Now we are coming these conditions. If y less than is equals to y1, then what will be the value? And what? If y less than is equals to this one, first what will be the point here? First write down. So if we just take this whole plane 1, 2, 3, 4, 1, 2, 3, this point will be 1, 2, 3, 4. As well as I'm considering the 5 here inside. And in this side, what? In this side or point set will be what? Point sets will be 6, 7, 8, 9, 10. Equal, because I am considering here equal side, equal, because of I am including 5. Now we are reaching this one. This is 5. So 5. So what will be the less than y1 value? Less than equals to y1. Just I am taking y equals to. So this value will be 1, 2, and 5. Now here the value will be 1, 2, and 5. If it is conditioned, and these conditions, if it is yes. So now insert side, what will be the value? This value will be 3 and 4 simply. This value will be 3 and 4. So now again doing the same job for right side. Just I am doing this job left side, just doing the same jobs as well for right side. For right sides I am just draw the same one, but because of this complexity I am same y-axis also, right? I am same y-axis also draw in right side. Just draw the y-axis first. Okay, okay. So what will be the projections of the h-plane? So projection will be here. I am using the same color. So the projections of 8. This is the projections of 8. This is the projections of 9. This is the projections of 10. This is the projections of 6. This is 7. between this I am not considering in this plane. So these 5 points. So what will be the median of this one? So median here will be, here what is the median? So our here in such scenario median is 9. So now we are splitting this. Now splitting this on this using by sample. By sample using this. I think it will be like that. Just take A. Okay. Okay. Just I am calling this 9. Instead of 9, I am calling here y2. Similarly here, if y less than is equals to y2. So if yes, if no. If y is equals to y2, so what point we have got this side? This side we have just we have consider also this point. Also just I am neglecting this 5 just because of remove the confusions. Just use the 5 this side. Okay. So what will be the point on this side? This side point will be 6, 7, 9, 10. This side's point will be 6, 7, and 10. 6, 7, 9, and 10. And this side only we have 8 points. Only we have 8 points. Just doing the same thing for as well. Now let's take here. Now let's come to this point. Now let's come to this point. Show what now left side. So we are doing the first we are doing the x-axis comparisons. Next step we have doing the same for y-axis comparisons. Now in the same in this step, in the third step, in third means this is the depth 0. This is simple. This is simple, the depth 0. This is simple, the depth 1. This is simple, depth 2. In depth 2 we are similarly using x-axis. Consider the x-axis. Consider the x-axis. So what will be the just draw the first median. First draw the median here. So first draw the median. First draw the projections. Projections. So here projections for I'm taking the another. So the some projections for this one, 2 is this one, and 3 I'm not considering. Just I am considering the x-axis. This portion means just see that we are dividing our whole plane through the sample by using the if conditions, some small regions. So this is the what 2. Now what is the projections in these regions? So in these regions our will be this one, and 5 I have taken this 5 in this region. So what will be the value? So we are simple here. Just omit this one now. In this step we are omitting just because 3 and 4 this region I am not considering. I am considering 1, 2, and 5. Simple. I am considering here 1, 2. What will be the median value? 2. Now we are dividing sample using 2 by x-axis. 2. Okay, no problem. I am just in hand. I am doing sure. This is the sample 2 I am using divide median. So if I have taken just see this region here, nothing point is happened. No point 1 is here. Just 5 is here only in these regions. So just write down this thing. I think then it will be. Suppose let's take this point is our sample x2, or I am doing x1 here. This is sample our x2. This sample job we have doing x2. So here in these regions, if our x is less than equals to x2, if yes, if no, if yes, if no, if yes, what our point will be, what our point will be 1 and 2, our point will be 1 and 2, and if no, if no, what will be our point? Our point will be only 5. Our point will be only 5. Just I am reaching a single point. We are now doing the stop this loop. I am just stopping this loop because I am just reaching a single point. And same process is continuing for each part, if until we have not reached a single point. Here we can just see that here we have reached a single point. Here we are stopping this loop. Here until when we have not reaching the leaf node. This is simple called the leaf node. Leaf node. Here also here it is also leaf node. Okay, until we have not reached a leaf node, we are continuing this job. So simple. If you just consider again, for y-axis we will divide this thing by using this line. Here we are just continuing this thing, just by simple, a whole plane will be divided a small chunk of planes. Here just simple continuing this. Okay, I think that's this process will be continue until. So actually, what will be the regions? What will be the logical regions? What will be the value of the logical regions? So to reach these regions, we have to overcome this root. This root means x1 less than is equals to x less than is equals to x1, then y less than is equals to y1, and then x1 greater than is equals to x2. Then we have come, means in such directions, means x greater than x2. So just write this thing. So to reach these regions, we have to consider this thing. So first we have x less than x1, this region less than equals to this one. In the second step, we have to make y is less than y1, and x is less than x1, and x is also greater than x2. This region, these two things, and y1 and y is less than is equals to y. This is the simple checking conditions of this region. This is the simple checking conditions of these regions. And if you see one thing, if you just visualize one thing, our divider is axis parallel, either x-axis or it is a y-axis. So just what are doing in it to build this KD tree. This is simple k dimensional tree. Here I am taking here k is equals to 2. This is 2-dimensional tree. Okay, for n dimensional doing the same job. First you have taken x-axis, then alternate our axis each other. Just first x-axis, then y-axis, then z-axis, then again x-axis. For 3-dimensional, just n dimensional, we are doing the first x1, x2, x3, dot xn, then again we have repeating for x1. It's doing the same job, each axis. So what we are doing to build a KD tree? Just summarize this thing. To build a KD tree, what we are doing? To build a KD tree, so till now what we are doing in KD tree? So let's summarize. First step, what we are doing in first step, we are breaking my space. That is, this one is the whole space. We are breaking this by using axis parallel lines or something. Simply breaking the whole space, breaking my space using axis parallel lines or simple planes into a what? Into a, if we consider the 2D, then line. If we consider 3D, then we planes and into rectangle. We consider 2D, for example, a cuboid. If we consider 3D and simple hyperplane, hypercuboid, hypercuboid, n dimension, n dimension. Okay, if we consider that. So we are doing this job and go through each axis one after. Second step, we are doing this by go through exchange the alternative. Not just going through. We are going to each axis one after the. What? We is the leaf. Till we don't leave the reach node. So we have doing this job. So first we are building a KD tree by using breaking my space into using axis parallel line or plane into a rectangle or cuboid or hypercuboid. In the second step, we are doing by changing the edge axis. If we consider the x1 axis, then next step we have considered x2, then x3 up to xn. Again we have starting the partition from x1. Just we are doing this job. And in 2D, if we just consider with 2D, we divided our whole spaces in rectangular portions. In 3D, we have divided our whole spaces in a cuboids, and in ND, we have divided our plane in a hypercuboid. Okay, in 2D, by simple axis parallel lines. This is simple parallel symbols. In mathematicians generally use this axis parallel lines by using simple rectangular. In 3D, we are doing axis parallel planes. By simple using cuboids. And ND, axis parallel here, axis parallel hyperplanes. We are using here hyperplanes to build a hypercuboid. The simple structure. This is the simple doing. Just extension. This is the simple extensions of the binary tree to. I think how this work is doing, how the partitions is doing by using simple k-dimensional tree. I think you have understood. Okay, just in the next lecture you will see by simple using the binary tree how we will classify, how we build a classifier algorithm. So we will see this thing in